So as you already know, in Godot 4.4, Jolt is going to be natively integrated in Godot. This means that if you go to project settings, and you go to 3D physics, you will have it here as an option to select. And right now it is not the default selected option due to the fact that there's still some stuff that needs some polish, some stuff that is not perfectly integrated. But maybe in the official version of 4.4 we may have Jolt as the default physics engine. And well, mainly in this video what I want to be doing is just trying it out a little bit for those who don't really know the advantages of using this physics engine. Because also I'm going to be comparing the exact same thing both in Jolt, okay, in 4.4 beta 1, and then in this exact same version but with the default physics engine. So just to be crystal clear with the setup that I'm going to be using, I will just have here, for example, a main scene, and I will add a mesh, or actually before a rigid body. So I just want to have a ball bouncing. Well, basically I had here the ball that I was creating. You just have a rigid body, a mesh instance, and a collision shape. And then we'll have here like the environment that you just have some markers where the balls are going to spawn. Here I have one marker that I shouldn't have over here. Let me delete it. And then well, basically I just have some walls over there that, as you can see, are also surrounded by some colliders so that the balls like don't escape or anything like that. And also here, let me quickly fix this rotation. There we go. And well, as you can see, this is the default behaviors that we have in Godot. They aren't too bad, okay. But well, the thing is with the performance, so you can see some balls start, well, they disappear, well, they are not able to collide, but as you can see, they start like pushing each other outside of it. And also well, the performance, if we kept this on playing, there would be some time in which this would literally break a lot. So well, this is what we have with Godot by default. Of course, we could keep a track of the FPS, of the number of volts that have been spawning, but well, with this you can get a good idea of what's happening. Of course, it also has lots to do with the size of them, also how the colliders here are put. This is just a pretty quick test. And well, by the way, I have this code over here that manages the spawn of the balls. That is quite simple, okay. But what I wanted to also show you, basically I want to decrease the size of the ball. So for example, let's give it here a different size. For example, let's make it half of the size, so divided by 2, and this thing divided by 2 as well, the collision shape as well, so radius divided by 2 and height divided by 2. And now let me increase the spawn interval to something like 0.08. Okay, so there we have it. We have now much more balls that are being instantiated. And I will also create here a for loop so that this is executed more times. So for I in range, let's say, I don't know, 10, and then I will do this like that. And now each time we'll get 10 balls, so this is going to work like this. So there we have it. Well, maybe this is a little bit too much. And let me also add here like some kind of floor or something like that, so that the balls like don't escape. So let me check which static body it is. It should be this one, yes. So let me move it up. Maybe something like that. So here we have what's happening. They start to basically leave the screen and well, the boundaries that we put. So well, let's try it, for example, Jolt. Of course, this will require a deeper benchmark, but I wanted to just show you this quite simply. And well, actually, as soon as you start playing this with Jolt, okay, that I have it over here, okay, selected, you start realizing the differences, okay, with the behaviors. It seems that they are just much smoother, much closer to reality, how they are falling, okay, how that you can realize the difference. And look at how actually Jolt here is handling collisions. There are much more balls than the ones that used to be with Godot, and it is still not breaking. It may break in just a couple of seconds when this gap is filled in. Right now it should start to break, but as you can see, it's able to hold them for much more time. So here you can see the actual potential of Jolt. Once again, there are lots of tests that should be performed to actually measure this. But well, I believe that with this super simple example, you can actually realize how powerful then Jolt is going to be. Or well, actually is right now, and well, how accessible it's going to be if it becomes the default physics engine. But well, right now it started to break something like 1 minute after I started playing or something like that, so it's huge, the difference. So let me know, what do you think about this?